Designers are very good at thinking outside the box, at looking at the bigger picture, communicating ideas and possibilities. And I think you can only evolve by building scenarios. And designers, they have these amazing skills of visualization, of communication of ideas, of materializing possibilities that I think scientists are not able to. So I think, I really believe that, designers are very good at that. But at the same time, they really need science in order to make these dreams possible, make these ideas and visions possible. So it's really collaborative. It's a collaborative effort.
Welcome to Design Drives, your audio experience about what, how, and why design drives things forward. A podcast hosted by Sebastian Gier, together with forward-thinking design practitioners from around the world.
In this episode, a talk with Nancy Diniz, who is establishing the world's first Biodesign education program in London. Considering the current global discourse on sustainability, global warming, and circular economy, I think it's worthwhile to find out how design can contribute to these global efforts, conversations, and challenges. Nancy shares how design and science, and specifically design and biology, can drive change by working together, and opens up a new space for designers to collaborate that I'm sure is not on the radar of many people in the design community. Enjoy. Hi Nancy, welcome to the podcast.
Hi Sebastian, thank you for inviting me.
So we are really glad to have you. You're really pushing biodesign forward, and we want to talk a little bit about that, the intersection between design and biology. But maybe to give the audience a little bit of context, where you come from and where you have been. So maybe you can tell, maybe in simple words, your journey.
Yes. So I am Portuguese. I have an architecture background, so I studied architecture in Lisbon, in Portugal. And then when I finished my professional degree, I started working in a research lab. It was actually Autodesk lab that luckily, for some coincidence, it was connected with some architecture firms. And then I started doing research in augmented reality, and I became very interested in technology and merging new technologies with architecture. At that time, we were using augmented reality as a conceptual tool. So how could we start conceptualizing, geometries in architecture in augmented reality as a kind of conceptualizing tool? So I became very interested in that, and then
Which technology was it for augmented reality? How did you use it back then?
So at the time we used this toolkit, which is called the AR toolkit, which is very cumbersome. We had these markers. I mean, it was very difficult to calibrate. You can imagine this was in 2002. The technology was very complicated to use. I mean, we didn't have these headsets that we have today.
Yeah.
High res. It was very complicated. It was very much based on coding. So I was working in this team with no architects, just with computer scientists, but it was very excited. And then I thought, of course in Portugal, in terms of practice, there were no offices working with these technologies. I decided to come to London, to the Bartlett, and do a master's in virtual environments. So I became very interested in technology, and then continuing with my PhD in interactive design, in this idea of real-time materiality, a lot of sensors, and how can we start making architecture react in real time, responsive surfaces, responsive materials. So I became very interested in computational design, and I started teaching computational design. And I started teaching in London in different architectural schools. So I went to Canterbury Architecture School, and then I became director of this program in Hertfordshire University in interior architecture design. So yeah, and then I went to China, and then to the US after, and then now I'm back in London. So I've been kind of like jumping around, which I think I like to think it really helped me in terms of as an educator to have this perspective of a global kind of perspective of the world. And, I love to travel, and I love to see the world. And I think it's very important as an architect to go and see the world and live in different places, in different climates, different cultures. So I like to think that it really, it helps me to teach, I think. And the world is global, and it's, I think, and diverse. So I like to think that kind of this really helped me to see the world in a different way, I think.
Yeah, absolutely. I think it's super important to get these outside perspectives. And what did you do in China and the US? Was it for education as well? Or?
Yeah, so I was in Hertfordshire. I mean, I was not doing any research. I mean, I was mostly teaching, and so I became a little bit antsy. I really wanted to do more research. So I went to China to found the first English taught program in China, which is a joint venture between the University of Liverpool and a Chinese university. So it was called Xianjiaotong Liverpool University. And it was a very, very interesting experience. We founded the first English taught program. In 3 years, we were validated by RIBA, which is the Royal Institute of British Architects that gives validation to programs. And so it was a very rich experience. I met incredible people. I mean, we had a very interesting department with foreigners from all over the world. And it's very nice to see actually now the department grew a lot. I mean, they are doing amazing things. But I was, again, not doing, I felt very isolated in terms of research at that time. So that's why I applied to the US and joined this really interesting research center, which was called CASE, which is the Center for Architecture, Science and Ecology. And it was very interesting because it was a program hosted by one of the biggest architecture firms in the world, SOM, and it was an opportunity to really real projects with an architectural firm and getting a lot of industry partners. So it was a great model, and this was a research center from Rensselaer Polytechnic Institute. So so it was interesting. So I stayed there for 4 years. And then I became very interested in biodesign. So that's why I came back to London again, because this program, I mean, is the first one in the world. I mean, there are other programs that are similar, but this one is the first one in biodesign. So that's why I came back. I mean, London, it feels like home, actually, because I lived here for 10 years. So I really like London as well.
Did you start it immediately when you were coming back to the UK? The new program, the biodesign program.
Yeah. So actually, my colleague Carole Colette. I mean, she's one of the people that really started these programs at Central St. Martin. I mean, she founded the Textile Futures. Then the Textile Futures became Material Futures, and she founded the biodesign program in terms of writing the program. And now she's going to be actively teaching it as well. But she didn't really want to be the course leader, so they opened this position. She's also very busy. She's the director of the Design Systems Lab and the Maison Zero Lab, which is an incubator at Central St. Martin. So she's very busy with these two programs. But she's going to be very involved in the biodesign masters as well. So Central St. Martin's has been a pioneer in terms of sustainable education.
So you were mentioning you were setting up the biodesign program. So I think now it's important for the audience to get a little bit of the idea what it is exactly, what's the setup, and what are you trying to achieve.
So the biodesign program emerges from these other programs that were set up at Central St. Martin's and other programs that deal with sustainable design. And we thought it was the moment to have a program focused mainly in biodesign practices. So it's and we believe that in order to tackle contemporary challenges like climate change, but natural resources depletion, low energy manufacturing, etc., you need to integrate other skills into traditional design courses. So we thought that this integration of biology and design skills, equal integration, is something that we think it's necessary. So we think there's a lot of demand in industry for designers to have these skills, to understand biology protocols, and how can you start integrating these as part of the traditional skills, because design and computation has been around. We integrate computation not just to 3D model and simulate, but also to make things. But so this has been around for many years, computation, but not biology. So sustainable programs have been around for a while, but they don't have wet labs, they don't have biologists teaching design students. So we feel like this integration is really important. So this is the premise of the program. How can we integrate living systems within the design process? How can we start designing with living systems? How can we start designing with living systems, for example, to grow materials, for example?
I think what was also very interesting when we were chatting before the recording was that you specifically restricted to designers, right? So not a completely open scope.
Yes. So this is what we are planning at the moment. It doesn't mean that in the future we can open it to scientists and engineers, but this is a design degree. We really want to design proposals, projects, services, products, systems. So we really need the design background to do it, because they have to do their own individual project, and it will be very difficult for an engineer or a scientist to develop their own design project on their own. So at the moment, we are only accepting design. This is a design degree. It's completely practical. It's not theoretical. It's a completely hands-on program there in it, and you have to be a designer, and we are not teaching how to be a designer. We want designers that can hit the ground running with these new skills and create sustainable design solutions.
Building on top of already existing design skills, basically, right?
So you can be a fashion designer, you can be a product industrial designer, you can be an architect, you can be a textile designer. So you have your own skills, and you're going to build on these skills with these new biological kind of skills that you don't have in a traditional design degree. So how can you start thinking? How can you start working in a lab? How can you start, which is, it's different. It's very different.
How is the setup? You said it's very project-based, but I assume there's also a lot of knowledge students need to gain upfront to, I think, work in this new direction. So maybe we can talk a little bit about that.
So the degree is 2 years, and in the first year, we have a unit where we are going to teach students how to work with different living systems. So the students are in school 2.5 days of the week, and 1 day of the week it's spent on the lab, just learning biology protocols with the biologists. So we have a biologist in the team. So it's an interdisciplinary team of designers and one biology, and also a lab technician who is also a biologist. So the students spend, I would say, 50-50 between the lab and the design studio and the computation lab studio as well. So this integration of traditional design craft, computational design, and biology. So it's kind of a very important, I would say, in 3 equal parts, I would say. Craft, computational skills, and biological skills as well.
You were mentioning living system, the term living systems quite often. Can you maybe explain this a bit more?
So we are planning at the moment what kind of living systems we can use. So we are thinking the common theme for the first year, every year will change. We are at the moment negotiating with some industry partners. So every year the agenda, the pedagogical agenda will change according to the partners and industry partners we will get. There's a lot of interest from certain industry partners to team up with us. We already have a collaboration in the Netherlands with the school. We're going to exhibit to work with them. So there's going to be some collaboration with other institutions, but also industry partners. And for the next year, we are thinking about focusing on bioremediation. This idea that, we can clean water, we can clean soil, we can clean air with working with living systems. So I'm going to give you some examples that you've heard. So for example, mushrooms, mycelium is something that it's being used quite a lot to create new biopolymers. You can grow a lot of things with mycelium. So for example, mycelium can clean the soil, can bioremediate soil. For example, think about soil that is very polluted with oil, for example. Mycelium can actually clean soil. So mycelium can also be used for binding waste. So you can recycle waste, and then you can grow the mycelium, and the mycelium can aggregate the waste and create materials like, for example, bricks. So we are thinking we are going to work with mycelium. We are going to work with algae. Algae, it's super versatile. You can make myceliums out of algae. You can bioremediate water. You can create biomass with algae. So algae is another living system we are going to work with. And then we are going to work with bacteria. Bacteria, you can do a lot of different things with bacteria. For example, you can also, bioengineer bacteria to do different kinds of bioremediation. So we are thinking about working with these 3 living systems in the first year, to give you an idea.
So let's imagine like there's a student coming from a product design background, and I did a project on vertical farming a couple of years ago, and for example there's aeroponics, hydroponics. These projects, could there be also, for example, imagining a service, how to interact with these new possibilities or new technologies? Or absolutely. Is it more in terms of taking these materials and getting them into a new product?
No.
Do you know what I mean? What could be the outcomes?
Yes, absolutely. I mean, the students can really develop, for example, a business around vertical farming, There's a lot of interest in developing this. I mean, there's a lot of startups that are doing this. Grow your own food, for example. You can really start creating these services and businesses around urban farming. How you can actually create the future of how can you start rethinking the future of agriculture? The fact that you can also grow stuff with no soil, with no natural light. These systems are very much in everybody's agenda. I mean, even now at the Chelsea Flower Show in London, there was a garden supported by IKEA and Tom Dixon, and they were exactly the project was about the future of gardening, the future of agriculture, and how you can start growing things with artificial lights, with no soil. So definitely green walls. Green walls was something that was very much explored at the research center where I worked. It was a big thing. How can green walls can purify air, and how they were doing a lot of experiments with people, getting them in a room with the green wall, measuring biometrics, measuring CO2 levels, and trying to really come up with quantitative data to prove that this actually works. So, definitely something we are interested in. And we have a garden, by the way. We are building a garden at Central St. Martin's. We have a garden at the terrace, and there's a lot of other people outside of Biodesign. They are doing research with plants, actually using plants to create textiles, sustainable textiles, etc. So we have a garden in the rooftop. It's very connected. For
prototyping and leisure.
Yes, exactly. It's true.
So I just was wondering how it is intersecting with other design disciplines, but you sort of were answering it, like, for example, how is biodesign connecting to, for example, service design? How does it connect to, even things like, how does it connect to user interface design? How does it connect to architecture? You're mentioning quite often.
Yes.
That makes a lot of sense. Or, can it be product design as well? Like, I think you can take it in many directions. So I was just wondering about fashion design is another example. You can take it into many directions, I assume.
We have a lot of interest from product designers, industrial designers, and fashion, of course, fashion.
Yeah, I assume fashion a lot because, talking about impact, I assume fashion is one of the major drivers.
Yes.
Why do you think it took so long until a program came up with that kind of setup?
Yeah.
Because, I think in other industries, for example, engineering, business programs, so on, it's more common since a longer while, but there are not so many design programs, and there hasn't been any about the intersection of design and biology.
Yes. Some programs have it as a kind of, courses. They have pathways.
Exactly.
So there is a lot of, sustainability has been around for a long time, and definitely design education as in general really touches upon, and they all have courses. Architecture, you always have sustainability courses, but it's mostly theoretical. It's materials, it's how do you build sustainable, it's around energy and performance, So there's always the perspective, how you can save energy, so you have to be sustainable. The reason why I think it's taken so long is the nature of education, to be honest. It's very traditional in many countries. It's in silos. It's not interdisciplinary at all. For example, architecture, it's a very complicated degree because of a professional accreditation. So schools have these very strict learning outcomes in order to fulfill them towards professional accreditation. So they cannot really be very experimental in terms of curriculum development. So this is one reason, I think. It's the nature of professional accreditation. And in engineer, I think that's the same problem. Which is the reason why I really like to step now away from architecture degrees, because it allows you to be more experimental. Also at a master's level, you can be more free, you can be more experimental. But what I think is the main reason, honestly, is the moment we are living with all these. We are living this moment where there is this urgency to tackle this kind of environmental crisis, I think, and this kind of biodiversity loss. So climate change has been around for many, many years, but people really didn't believe in it. There was no data. I mean, it's very difficult to prove. Climate is very dynamic. There was no data to back this. So unfortunately now it's kind of real. It's real. It's not kind, it's real. And it's very difficult for governments to kind of deny it, and because you see it and you see the really depressing outcome every day in our lives. So I really think this is the moment. I mean, you mentioned the Cooper Hewitt Museum in New York, but you see all these museums now. Today Vienna also has another exhibition. I just saw it online. But the Milano Triennale, there was an exhibition of broken nature. There was at the Pompidou the Living Factory. I mean, at the moment, there's these 4 institutions that have exhibitions on biology and design. I mean, it's no coincidence why everybody's talking about it. And politics, I mean, politicians, you see the European elections, the Green Party, suddenly got more votes. And I think this is no coincidence. So I think there is a demand for it in terms of design industries. So all over the world, these programs are becoming kind of more mainstream, I think. They will become something that, I mean, and another thing is facilities. I mean, having a wet lab is not something you find in an architecture school, You have to invest in these facilities. So, I mean, it's a new way of designing, and it's a very important and I think it's finally schools have realized that you need to really teach these skills. Biology is very important, but it has to be integrated in design. I mean, biologists, they cannot integrate these things into design solutions. That's why it's so exciting to put these people working together. Biologists, they are very good at doing their experiments and everything, but they cannot apply them into design solutions. So that's why it's so exciting, this teamwork.
Yeah, I assume there will be more programs popping up in the coming years. How do you see the connection? You talked a lot about sustainability, but maybe talking about circular economy as well. How do you see this connecting to the program and
so again, there's a lot of talk about recycling. This idea that we don't need to actually create matter so much. We can recycle matter. So this idea that we can reuse things over and over again, and things can actually go back to nature. So there's a lot of projects that deal with this. How can we work? How can we make from waste? And then how can waste then go back to nature? So there is a lot of projects that deal with recycling agriculture waste, for example, all the things that agriculture produces. If you think about corn, if you think about wheat, if you think about coconut, if you think about all these things that really leave a lot of waste behind because of the industry. And how can we really reuse these for materials, for making things, not just architectural materials, but for producing, for example, products, furniture, textiles. So there is this, this idea of circular design. How can we stop making so many new materials that are so toxic towards the environment? If you think about textiles, it's unbelievably harmful towards the environment, the dyeing industry of textiles. But also, if you think about materials in architecture, I mean, all the waste we create by creating the steel industry, even concrete, all these materials. I mean, I'm not even thinking about marble and all these noble materials that completely, timber. Think about timber, for example, and the depletion of forests and all this negative impact on the environment. So there is a lot of interest on developing green materials and not have such a negative impact in terms of embodied energy. Embodied energy is the total energy that costs to create products. If you think about embodied energy of any product, it's the people that are working there, materials, where it comes from, transportation costs, energy costs. So how can we start offsetting all these environmental impact, carbon footprints? So this is something that, naturally architects do, but they don't really have the knowledge then to create these kind of products, because the education of architecture is just so broad and you need to study so many different things. You don't actually have time to prototype new materials.
Yeah, exactly. So you don't have really time for that. I think, and I think a program like this helps. I think another topic that's really interesting is the topic about behavioral design, because I think also some of the things I learned during my time in New York is that very often people are looking for these big things to really make an impact, while the daily habits, the small details, they add up over time, and by changing them, you can have as much impact as doing the big thing that people always crave for. So I think that's also very interesting. So I assume this is also something to think about if you even thinking about architecture, right? How does the experience within the solution sort of create a certain habit or create certain behavior? Same with a product or service. Does it make you reflect about your behavior, for example? How can you make people reflect about what they are doing? Because I think that's always a good way to make people change, right? If you tell them to do things, then it's always hard. But if they reflect for themselves, so there's also, I think, this side, besides obviously this whole topic about materials and innovation, about new processes, but then I think also about experience, basically, that's between the potential user and the solution.
Yes, that's a very good point. And I think it's difficult to really make people change
it's very difficult.
Their habits, and and this whole consumerism and the people really want to have a comfortable life, and sometimes it's difficult to change these habits.
You were mentioning generative design. Can you tell a little bit about the programs you're using for that?
Yeah. So of course, being an architect, I'm very much coming from the skills of an architecture. In an architecture, we are very good in terms of 3D modeling. So in terms of simulating form. So there's an element of form finding, right, that it's important, that in this case is going to be very much generated from the behavior of living systems, the behavior of nature. So there is this element of biomimicry, biomimesis, which is something that sometimes is very misunderstood. They think it's about copying, nature forms, but it's actually not that. It's actually understanding that there are very intelligent behaviors in nature and in animals that we can really learn from. For example, the ants, they do these amazing termite formations where ventilation is fascinating. So the ants really understand ventilation and they build these amazing structures, for example. So this is an example of where biomimicry is a great example to develop, a ventilation system. But it's not just about, mimicking natural patterns. It's not about that at all. It's going beyond that very much. So, we are going to use a lot of software to model form, that it's performative, that it's efficient in terms of material, the amount of materials you're going to use, that it's going to be efficient in terms of any kind of criteria that is set up. So you're going to model it in Rhino, probably, Rhino software or CAD software, and then you are going to use Grasshopper, which is a plugin for Rhino, to do parametric design, because you can really generate a lot of scenarios very easily. If you use Grasshopper, you can start simulating many things. You can start simulating physics, you can start simulating light, you can start simulating different kinds of, you can even start simulating living systems with plugins from Rhino. For example, slime mold. I mean, we've done that. I've done that in my practice. We simulate living systems with these plugins for Rhino. And then we use this to simulate design proposals. And then we use digital fabrication to materialize it. So hopefully we can use digital fabrication to create molds, but we can also use digital fabrication. We can also use, for example, 3D printing. We can also start thinking about printing biological matter, for example.
Yeah.
So we can start making things with biological matter. So that's quite exciting. So biology itself is not just about learning how they behave and learning to harness, for example, mycelium. You can also start thinking about 3D printing mycelium. So there is a lot of exciting new technologies with 3D printing that we hopefully are going to use. But it doesn't mean that all students have to be, they have to be masters in computational skills. They can also be very analog. Think about, some of our students are going to be very talented in terms of craft, in terms of doing things with their hands. Imagine these students. They can really start knitting textiles made of algae, for example, or algae. Yeah. So there's going to be a balance between, computation and craft, which is something that it's very strong at Central St. Martin's. And with biology, so I think it's going to be an interesting mix.
I think there's a lot of things to learn. I think and to explore on the physical side, like you were saying. I'm just wondering, maybe as a last question about the biodesign program, a big topic is also finding the right applications, right? Finding the right the right spot, basically. So I was just wondering a little bit about the process of getting there. To getting maybe the step before the jumping into the craft, like using some design methodologies, for example, innovation methodologies to come up with, for example, the right user need or the right problem to tackle. Yeah. Is that also something you look into, or how would students basically find the focus, right?
Yes, that's really important. That's a really important point, and I think, in every master's and PhD degree, that's a very difficult thing to do. How you're going to focus on and kind of narrow into a realistic topic that you can manage, especially in a master's that you don't have much time. So I think there is a bit of entrepreneurship that we are going to instill in our students. Myself, I'm part of a startup, so this thing about knowing the market, knowing the user, really understanding who you are designing for, it's crucial, we believe. So we really need to understand who is going to be our user, who is going to be the people that are actually interested in what we are doing, what is the market for this. So I think, I believe that more and more entrepreneurship is going to be part of all the educational programs. And we believe that it's going to be a little bit of an incubation of new future design future products and services. So we believe the program can really catapult a new generation of biodesigners that will be very successful. And of course, in terms of career paths, they can really work as an environmental consultant, working with scientists and designers, but they can also start, creating their own project and their own products. Or you can just go back. We really believe, I think I told you this before, but we really believe that if you are an architect, if you're a product designer, after this degree, you go back into your practice and you are still an architect, but you have an enhanced, an augmented set of skills that you can use to tackle new challenges. So you can go back to your studio, you can go back to your company and do things in a different way.
In a new way.
Yeah, in a new way.
Makes sense. Super interesting. You also run Biometers. Maybe you can give a little bit context about the work you're doing there.
So Biometers is a startup company that I am running with my partner. So we run this little studio in New York City, and we started this new company that is just focusing on biomaterials. And we are using we have been developing this new material ourselves. So we grow mycelium ourselves, and we've been mixing it with a bunch of different waste products. And we have been developing this new kind of material. And we've been doing acoustic panels mostly, and just other objects, just to prototype the material in itself. So we are doing a lot of experiments with bioprinting this waste and growing the mycelium on it. And so the idea is to have a material that you don't need to fire, you don't need energy to produce it, it just grows on its own. And you can actually have highly performative materials in the case of the acoustic panels, for example. They can really, they work quite well. Of course, we need to do a lot of testing. So we are part of this incubator in New York called FutureWorks. We are going to present our project, the last pitch in August, to investors. Hopefully we can raise a Kickstarter campaign at the end of the year, until the end of the year, and hopefully we can really start, having a team and hire people to help us to get it to another scale, because at the moment it's two of us making things on our own. How can we start making more products, taking this to another scale that it can be, a product.
You said it's acoustic panels?
Yes.
Maybe you can talk a little bit more about the product you're working on. So
it's just tiles. So it's like a tile system of 10 by 10 inches. And we are working with different kinds of relief and geometries to see which ones are the most effective in terms of reflecting sound and absorbing sound. And so at the moment we have a lot of different iterations of these patterns that we are developing. And
generative design, I assume.
So we are just hopefully it's very difficult to do a simulation of sound and to actually simulate how efficient they are. So we are hoping to get someone from the acoustics department. We are at the moment contacting a few schools that can help us, because it has to be an engineer to have these calculations made. Designers do not know how to do this. So we are going to test these panels to make them, to convince people that they actually work. At the moment, we are having this whole wall made out of them. So we are manufacturing these panels to fit this big wall, in a room, so we can properly test them.
Yeah, I think you need, designers can't do everything, right?
No.
Yes. Is there a website or an online link where people can find it?
Yeah. We have it's one of the links that from our website, Augmented Architecture. There is one link that it's called Biometers, and we have these. It's actually two projects. There is one Biometers and another one which is Somiko, which is the acoustic panels. I can send you the links. But if you go to our website, augmentedarchitectures.com, you'll see the links.
We're going to put it into the description. You were mentioning the term augmented architecture. I think that's a very interesting term. I came across the first time when researching a little bit about you and your work. Maybe you can tell a little bit about what do you mean with augmented architecture, about this term.
So this was a long time ago that I came up with that name in 2004, I think, when I think
it's very interesting.
Yeah, and it was like inspired by this idea of architecture being augmented with real-time properties. How can architecture react in real time? So this augmentation, how can we start embedding, for example, some intelligence in architecture? How can architecture can sense, which is a very old kind of concept if you think about it. It started in the 1960s at the AA. All these cyberneticians started coming up with this idea of how can architecture be responsive, can have these responsive properties, how can architecture can sense, how can architecture can react to stimuli. So the whole practice started with this idea very much based on this ideas from the 60s and 70s, interactive architecture. So how can we augment, static traditional architecture with these layers of intelligence, whether it's, artificial intelligence, but mostly computational actuators and sensors. How can architecture react to light, to sound, to movement, to people, etc. So that's how it all started, and now is moving into biotechnology, which I think is the future, obviously.
Yeah.
But I think computation has been around, artificial intelligence, but artificial life, I think it's something very exciting. How can we start replicating living systems, right? Which is something that we've been trying for a long time, but I think finally, biotechnology, can really play a role on that.
I'm wondering a little bit about your perspective on the uniqueness of what designers and design can contribute to the whole topic of sustainability, biodesign, circular economy. Because I know I guess there are many other sides that also contribute. For example, I assume there are a lot of innovations and a lot of impact can come from material science and chemistry, and I assume that's a major collaboration partner for you. And that's more of a technical enabler, right? But now it's the question, like, how do you apply it? How do you implement it? And maybe we can talk a little about, I think I would be interested in your perspective on the unique contribution designers and design can make.
I think, for example, where I was working, PhD students, they always worked alongside scientists. There was a very deep collaboration between design and science. Engineering, for example, computational, but we mentioned computational a lot, but because of all the data visualization, the importance of big data, blah, 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 that everybody's talking about. Data is super important, but we also, like you said, chemistry, even mechanical engineer, electronical engineer. These are really exciting and necessary fields. Think about neuroscience, for example, super interesting to connect with cognitive scientists. So everything is very interesting, and I think more and more design and science will be working together. So this idea, which is very difficult because we are still very different people, scientists and designers, we think in different ways. It's very difficult to work together still. It's a big struggle.
You made your experiences.
Yeah, it's it's very hard, but it's also very beautiful when it works. I think it depends on personality, to be honest. Sometimes you find scientists and their personality really match with designers. Sometimes it's designers that are like more scientists than scientists. So it really depends. You have really artistic scientists, and sometimes you have these designers that are completely an engineer, in their minds and in their soul and the way they think. So it's difficult. It's difficult to think. I think it's difficult because it's the nature of the industry as well, how we apply these things and how do we have to work. Scientists think designers are very generous with their time. I think designers, in my opinion, design is very undervalued, underpaid still. We are very generous. We like to dream. We like to really speculate. Scientists, they don't have so much time. They are very organized with their time. So it's difficult for us to really work together, I think. But then sometimes you really get along and the personalities really, everything coalesces and it works, and it's the only way to actually make it work is when you have these two worlds coming together and really be creative and solve problems with these within these two different worlds. So I really think that's why I believe that biodesign is such an interesting format, because it really allows you to understand these two worlds, because it's very different to work with living systems. Biology never really works sometimes the way you expect it. Things don't grow the way you think, things fail many times, and designers are not used to that. Designers are used to working with, things that are not living. So it's kind of like, it's easier to kind of like predict the failure, I think. So it's different. I mean, it's different worlds, and I think people more and more have to really be hybrid. They have to be hybrid in different kinds of skills, and they have to. Actually, you have to learn how to talk with the scientist and vice versa. And vice scientist needs to learn how to talk with the designer. So you need to actually develop skills in terms of communication, in terms of understanding exactly what is possible or not, because sometimes something that really happens to me, scientists become very frustrated. Sometimes I just ask for impossible things that are not really possible. So I think it's very easy to come and, for example, genetically modify some cells, and it's not easy. It takes, it's expensive, it takes many months, etc. And I think, doing a drawing, it's easy. Doing and making a computational drawing takes months and months and months, and you need to study 5 years in order to do that. So, people think it's very easy to do 3D modeling and to do beautiful renders and to make 3D prints. I mean, it takes ages to do 3D prints. They don't understand how hard it is.
Yeah.
I mean, I was doing a 3D print last week that took 3 days to print, for example. People think it's not possible. But yeah, it took me 3 days to actually print this mold, So it's really about understanding how difficult it is to grow things, how difficult it is to make beautiful things. It's also very difficult,
Mm-hmm. I think this is really interesting. I think, and this relationship you were just talking about, how do you see the role of design and the role of science, and maybe the different contributions they both put in?
I think they are equally important, because sometimes the designers are not thinking about something that science can do, and they can really help to solve a particular design problem. And so I think it's really 50-50 collaboration. Mm-hmm. And I think the designers are very good at thinking outside the box, at looking at the bigger picture, at communicating ideas and possibilities. And I think you can only evolve by building scenarios. And I think scientists are not very good at that. Designers, they have these amazing skills of visualization, of communication of ideas, of materializing possibilities that I think scientists are not able to. So I think, I really believe that, designers are very good at that. But at the same time, they really need science in order to make these dreams possible, make these ideas and visions possible. Mm-hmm. So it's really collaborative. It's a collaborative effort. Mm-hmm.
It's maybe comparable to working with an engineer in a way.
Yeah.
Right? Yeah. Mm-hmm.
Yeah, exactly.
How do you see biodesign evolving, or the role of design in the aspect of sustainability? The ultimate impact designers can have going forward.
So I think it will be an area of more and more investment. There's going to be a lot of industry companies investing in bio products, biodesign, biotechnology. There is a lot of money in biotechnology, but they are all in the medical and pharmaceutical side, field. Mm-hmm. So I think there is a lot of interest for big companies, big corporations to invest in sustainable products. So I think that alone will really push for the industry, because you need investment in order to work in this area. You need to create, labs. You need to really work with biologists and scientists. So I think there is this side that will create more opportunities. There is a lot of companies, I don't want to mention brands, but there is a lot of companies in fashion, in shoes, the sports industry that they really want to invest in this. But also big other companies that are making furniture and making architecture, in the industry of construction, which is a very traditional conservative industry still. We are still building with concrete most of the time. So it will take some time in order to change this, but that's why I think it's easier for fashion and product design to implement these things in a much quicker way. But I really believe that, the generation itself, will demand that we actually protect the environment, but not also the environment protect human health. So I think all these issues towards pollution it's a very serious thing. I mean, there is data now that really proves that people are dying of air pollution around the world, in children's health, asthma, etc. So I think it's something that will be an urgent matter for all these politicians to actually reinforce legislation around industry. You see, I mean, single-use plastic is being banned in different parts of the world, even in the US, which is a country that, is well behind in terms of environmental policy, is well behind Europe. But even in the US, they are starting to implement this legislation, and it has to be mandatory. It has to come from the top in order to make this happen. So I really believe that it's something that, unfortunately, it's coming from the environmental crisis, I believe.
Mm-hmm. If you think about maybe Dieter Rams' 10 principles of good design, I would be super interested in how these 10 principles, for example, would evolve based on your perspective. You were just mentioning human health, making products circular. So I'm sure you don't have it on hand. You don't have it ready. But I would be very interested in that perspective.
That's a good challenge, Sebastian. That's a good challenge. But you know that the circular guidelines towards sustainable design had just came out. So there was these guidelines that Nike wrote with the help of Central St. Martin's staff and students. So it's available online. You can download it. And there's this, I don't know if it's 10 principles, but they definitely identified guidelines towards sustainable design. So this has already actually been done very recently. It was like last week that Nike published this, it's called Guidelines.
I saw it.
Guidelines towards sustainability, which is like recycling, circular. So, I mean, it's kind of like these basic but fundamental principles of how to design in a sustainable fashion. So I would say really, I mean, the biggest one, for me, it's always energy. I think energy is a very important kind of notion. If you start thinking about how to save energy, how do we start not using, if you start looking at how materials are produced, and if you really start understanding the amount of energy you need, it's quite amazing. If you think about ceramics, for example, it's so unsustainable. I mean, ceramics, people think it's amazing. I love ceramics. I really do love ceramics, and I've done ceramics in the past. But if you think of the amount of energy you need to fire ceramics, it's unbelievable. It's quite amazing,
Yeah.
Amazing the negative impact in terms of energy that you need to actually, fire ceramics.
Yeah, absolutely. You were mentioning you were traveling a lot. When I'm traveling, and if I'm in a new country, even like you're already seeing it when you're on the airplane, depending on how the food is packaged, traveling to some countries and with certain airlines, much more plastics, things, they have much more waste versus going to other countries. I think this is also very interesting. The awareness is very different.
I agree with you. I mean, waste is something that really, I'm fascinated by the fact that I'm fascinated by the fact that I think people are very aware of waste, because it's something that it's a very daily kind of, like you said, it's a kind of a behavioral kind of thing. People have to recycle, and people are very aware about the amount of waste we accumulate in cities and landfills. So waste is something that it's something actually very fundamental in terms of sustainable design.
Yeah. There was a quote recently I was reading that the problem is not that we have plastic, that we use plastic. The problem is what we are doing with it and how we're treating it, and that we are actually not recycling it. And I think then it comes down to design also, right? How do you find the right applications, right? Yeah, thank you so much, Nancy. I think this was super interesting.
Thank you, Sebastian.
Yeah, if you have at some point your 10 principles about good design from that perspective, let me know, then we can make a new episode on that.
Yes, actually you could come to Centro San Martin and visit us once we get the final shows and reviews. If you are in London, I mean, anytime you are in London, you are welcome. I think you would like to come into the school and see the work, you know?
Yeah, absolutely. I will jump by if next time I'm there. Yeah. So thank you so much, Nancy.
Thank you very much for having me and inviting me.
That was the episode. If you want to give us feedback on the podcast, have something to contribute to the next episode, or just want to get in touch, feel free to connect with us either on Facebook, Twitter, Instagram messages, or simply via the designdrives.org website.